I do write new versions and support the language, like Sharp 9 that I will be talking about. And what is your opinion on that? Well, there's a lot of new features. Sharp 9 was in development for a year, unlike previous versions that usually take 2 years, but there's so many features that I could not put them all on my title slide. At the same time, we have a lot of improvements that will definitely bring new possibilities to write code in a better way, like Lambda or local function attributes, and a lot of features that will reduce the code, like the records, and pattern matching that gets better and better with each and every version, and I keep using it right now, and I suppose that I will be able to rewrite a lot of code with it. And we've also developed the null functions, and I think the compiler has rethought how we actually work with it, and well, yeah, cool. And I already looked at the plan of your presentation, and it's quite impressive. What is the feature you await the most? Answer. Well, I would like to touch records more, because I only applied it in my local projects, and I think they will be really beneficial in any of the projects that moves to Sharp 9, and I think I will be using them in my work. And the pattern matching is of interest, because I keep using it right now, but for now there's some glitches that make me refuse from using it in some of my methods, but in Sharp 9 it will be better, and I hope it will actually be even more useful. Well, I think that we have more features now in Sharp 9 than possibly a human being can handle. So do you think we have too many functions? Answer. I thought local functions, for example, is a bit too much, but now I use it in every second method. And besides that, returns or performance features in C# 9 are needed only by a very limited number of people, and sometimes you just don't need to know about this feature, but for those who need it, it really saves lives. So I don't think we need to get rid of anything. Put level statements is something that I don't like, because I don't write main methods 10 times a day, but they might be useful for people who just start to learn the language. Well, that's probable. Let's not keep our audience waiting, and I think let's just start with the presentation. Okay, good. Hi, my name is Andrey, and I work for JetBrains. As I said, I support C# and rewrite the code, and I will talk to you about the new features that I included in the new version of the language. Will be available in a couple of weeks, and we will be using them. And I will also cover what you need them for. So records and pattern matching will be used by pretty much everyone, about changes in nullable reference types. I hope you've started to use them, at least in your pet projects, if you don't have time to move your main projects to that usage. About just some nice features that will let us write the code just a little bit better. Runtime covariance and new capacities for optimization. Let me start with, as I said, the most pleasant and nice and sexy feature, that is record. So many of you heard about this thing, and many think that it's just short syntaxes for types, but some think it's a class or a structure. But let me show you how it looks in C#8. So imagine I need a class with a number of properties. I create the constructor, and usually need some equivalent functions. So I need to reload the get hash code, and so I could use the equity and equity repeat operators and some support methods like deconstruct to deconstruct the type into the variables that it consists of, to string, to debug it and have a look at what type am I working with. And of course, if I might need some cloning objects for cloning methods for the objects, usually with name, with age, etc., to understand which property we are changing. So imagine the amount of code for just two properties that we already mentioned, and how much code it will take to add another one. And this all will now just be included in record that you write in one line, and the compiler will do the rest. So it will generate not only the type, but all the properties within the type. And record is a reference type that you could define in C#. 8. The structure is planned for C# 9. This is a value semantics class, something that we await from the structures usually. So equals and get hash code does not use the values of the properties, but the types that are there. And also, record supports inheritance only between records so far. So if you cannot inherit a record from a class, and the compiler will not know what is the semantics you expect, so this is prohibited for now, but you can still inherit a record from a record. So you just show which parameters you would like to add and inherit, and that's it. Be very much aware, C# is a register-sensitive language, so you would need to be very attentive here. And with methods, we don't need them anymore, because for records we have new syntaxes for cloning it with changing of a number of properties. For example, if I create this student object, I can get a student of the next year, which will have a new student ID, and I will use the with method, and in the here I will just change the properties. It will be better performance, because I can change any amount of properties within this, and this will also remove the boilerplate problem, because otherwise I will have to define the with age not only for the person but for the student, which is inherited from the person. And if we have a lot of inherited classes, then we will have with methods and class declaration sigters in our compiler looking like this: more than 500 and inheritance from syntax children. So we need to highlight that sometimes the value semantics can be uncomfortable. So you get hash code from an object like a person, and you, for example, start to calculate the hash code of the apartment of the person that lives in, and then you find the person that owns the apartment, and then you get back into the calculation of the hash code from the person again. So you can just redefine your hash codes and methods like equals and get hash code, and you can actually add any records there. Instead of semicolon, you just put the brackets and add whatever you need. So you can even avoid putting the properties in the constructor. You can just replace the class with a record. So what's the difference with the class then? The difference is in value semantics. So the compiler will add equals, get hash code, with, etc. The only thing that will not be present in such syntaxes is constructor and deconstruct, because the compiler will not know the order of those properties. You can even change the approach and define some of them as properties of the constructor, and some as an optional. So you can define it like this, and then age name will get into constructor and deconstruct. And the last question with the records are the attributes, because for those types you need to define serialization, and you use the attributes to and it's unclear where you need those attributes to go to the constructor or to the properties, and you can actually then name it, show to the compiler where you want this to go. So the property will belong to the attribute that is generated. So, to summarize, record is a class with the value semantics that I think will be used in all the projects with C# 9. And all the methods needed will be created by the compiler. Records and classes need not then to be mixed during inheritance, and the new syntaxes will change with properties. So this brings us to the next interesting topic with init access instead of set access. So the records are not the only place where it works. You can use it anywhere. You just put the init instead of set, and you get a new type of set accessor that is available only in the constructor and initializer. And I will tell you more about how it differs from the other types. Imagine we have a car with some max speed parameters set at the factory and a driver that can change every hour. So for the maximum speed available, I would use init, and for driver I would use set. And I can define all the properties I need, and here I see the difference between read-only and get-only properties. Read-only and get-only I can use only in the constructor, not in the initializer. And if I try to change them, I can change the driver, but the compiler will prohibit me from changing the speed, as it should not be changing after the object is created. And the question is why we need the feature that is pretty much the same as everything else. And if I have some hierarchy, like with the car that has some speed, I define it in the constructor, and I need to duplicate it. And if I have a lot of inheritance, then it's not convenient, because especially if I have some default value, because when I have that default value, I still need to call the constructor and call the base methods in all the children. And to avoid writing all those constructors, we just put the properties with public setter and put the values there, and we lose immutability then. I have no guarantees that this setter will not be used after the object has been created. So now I can get those guarantees using the keyword init. I declare the property, I put some default meaning for it. Those who are satisfied with it will just use it, but I don't have any special constructor. And it can be also redefined with initializer. So if you have properties that should not change, then use init. Or if you use one of those templates, public property that is needed only for initialization, or get-only property with a default parameter, you can just use init now. And let me talk to you about pattern matching. It's a great feature. It gets better and better with each version, and pretty much in every file now, at least for me. In C# we could only check the type and declare a variable. In C#8 we can check the properties, so I can check that the car is driven by the person named Andrey, use deconstruct. And in C#9 we have this feature that allows us to check which transport type is used on each road. So, despite I don't plan to use it, I still need to tell the compiler that I'm doing a type test, not checking the variables. So now the compiler is quite smart, and our code is getting clearer. So we can remove that part, and it will still work. Also, an interesting thing is that it's why I refuse sometimes from using the pattern matching. I need to name them all and duplicate the expression after the arrow. And if the expression is quite long, it's hard to make it happen. So now the compiler has solved this, and I can use OR and put as many patterns as I would like, and they will all lead to the same expression. So regardless of whether it's a bus or a car, they will be allowed to use the road. And I also use part of the operating code to check the truck weight. Why I had to use it? Because I could check the constant for 5 or 3 tons, but I could not say that I am satisfied with any value higher than 5,000. But now I can do it. I can say I enjoy anything more than 5 tons and less than 3 tons, and I can also rewrite this switch so that it has another switch expression that checks for the weight of the car. And actually, the values here are not in the right order, and I will not be able to understand the amount of my. And it will be interesting to make it like this, to put higher the 5 tons. But then I get the unreachable case, and I can solve this by the new type of pattern and showing that any value from 3 to 5 tons needs to be paid. And now the compiler can check that I actually covered all the potential values, and if I use this I get the exception with 3 and 5 tons exactly, that's getting unreachable. And another case that maybe I did not have any other types of modes of transport. So at some point in time I will add motorbike or bicycle, and each and every time I add something I will need to find all the switches and add a new case. So this is not convenient. So what is doable here, and what I meant, is to say that I am fine with anything apart from the trucks. And now I can use the keyword not. I can say that everything that is not a truck will be allowed, and I will not have to update this switch every time I add a new type. You can also combine it with a more complex pattern and say that everything that is not a truck, that is weighs more than 3 tons, is okay, and because I have no operative code besides that, then it will be checkable for covering all the values, but might be less readable. And one interesting thing is that you can also you cannot define the property, the variable anywhere. So because I can combine the patterns using the AND keyword, I can use one to check and another one to announce the variable. Unfortunately, I cannot break the 2 values into 0 and other numbers, and the compiler will not be letting me to announce the variable in all the parts. But with not, we can define variables. There's a lot of such things in my code when I check the object for for being of this type. I did not like this pattern matching with not, with the variable in brackets, and now I can make it the same using the not. So now if it is not a card, then I can use it. That's it for pattern matching. I think it will find its way into many of your projects, and I would like to also talk about generalized types annotation. That's a great feature, allowing you to get less null reference exceptions, and we have a number of changes in it. First is with nullable reference types, we can annotate the generalized types, and I will show you the solution. We have a new constraint where t default. Pretty much no one now understands what it means, but I will tell you more about it, and a couple of new annotations. And also the compiler team has run a number of improvements that actually give you less warnings and be faster. So if you were moving a project to nullable reference types, then you probably saw the issue when you try to announce a generic type something, and then the compiler would tell you that it doesn't understand the question mark, and people often leave it unannotated and get more issues further on. Some would find some attributes, and they try to get the difference between a low null and this low null. We have in every parameter some annotation now that says that we can compare those even with a nullable type, that we cannot get hash code from not nullable and stuff like that. So it's much easier now to write this code. You can use the same syntaxes with a question mark, and the compiler will get it. Also pay attention that this allow null is still available, so you can still use the nullable type, and if you want to prohibit it, you need to announce this explicitly. If you were filtering the collection, the compiler will ask you to check this variable for null, because it doesn't understand that you checked it using the Lambda. In many other languages, it's solved by where not null, and gets a collection where you can get it, and returns another collection that does not have it. So you cannot actually get the same type of collection in the same syntaxes in C#, but now the syntaxes with a question mark will just work, and my recommendation is that if you use lim_com, just add this method into your project, and I think it will be actually useful, and I hope it will get into the framework, and it is actually convenient. One more example of generalized reference type is where t default. So imagine you have base class and a child, and you want to get from allow null to new shortened syntaxes, or you just develop that inheritance chain from the ground up. So you put the question marks there, and the compiler tells you that it does not understand which method you would like to reload. Why does it happen? The answer is that C# already had that syntaxes with the question mark, but it actually meant differently. So if you have a method that gets the nullable structure in your base class, then the compiler thinks that you use the test structure. So how do I reload the something without constraints? And we need to tell the compiler that there's no constraints, that this is not a structure. And in those cases, we can use that new constraint where t default. You can only use it in overrides and interface implementations. It does not give you any new options. It just tells the compiler that there is no constraint, and it should not be there in the base method. So also in C# .NET 5, you have some annotations that solve some of the scenarios for the reference types. And immediately when people started to use it, they saw that in constructors and compilers, you often hear unpleasant warnings, that you cannot understand. For example, I'm initializing some field that I need to move into another method, and the compiler cannot now say that I have initialized all the properties. Some found out that you can put null everywhere and remove that warning, but don't do it, because then you just cheat with the compiler. So now we have the member not null that allows you to check for the contract, and we did not forget to initialize that field. So there's a couple of agents when you have a type and your properties, and one of the methods checks for null. For example, there can be a driver that can be absent, and another one checks that he's older than 18. And if I if I try to get the name of the driver into the console, the compiler would say that I cannot make it because I need to check it for null. And it is because the compiler does not see the connection between the driver and has driver. So I need to announce this connection between those two things. So I use the member not null, and I say that if it's true, then this also is true for the parent. And some things that were present in the language. For example, you did not have static local functions, you did not have lambdas, you had attributes, but not on the local functions. You could use target expressions like switch or default, but you had to add casts for example, and also target type new expressions. I think pretty much everyone was writing some things like you announce a field, you type equals new, and the same type. Dictionary string linked to this person. If it's 200 symbols, then it's very long line. But if we just put the new now, then the compiler would actually understand what is meant. So you can put value in that dictionary, create some list, put the size of that list into the constructor, and it will work. It will not work with interfaces for obvious reasons. The compiler does not know which types I would like to implement this dictionary for, but if the compiler knows the types, so for all the current variables, properties, and methods where the argument types is known by the compiler, then it's all fine. The readability may suffer. Now it's a super valid code on C#9, but probably not everyone will be able to tell which new type is created by those expressions. But the initialization is now easier. If you are tired of holy wars about tab or space, then tabs versus spaces, then you can now fight over where you put the type and the variable. Please remember that you might need to read this code or someone else, so don't overuse that feature. So also we have that conditional expression with the con, and I think you saw multiple times when you have one branch of execution and the other, and the compiler cannot get. You need to tell the compiler that it's enumerable. The compiler can still not get the common type, but you can now put it into the variable, not in the cast. So the compiler would know then that it needs to be converted to this type. Or just skip it if it's known to the compiler. For example, you already have the variable of this type, or just you send it somewhere. And we also have static Lambda expressions and anonymous methods. So you say keyword static, you use keyword static in front of Lambda, and then the compiler will know or give you the warning, and if you create that short circuit. You can also use discards in the parameters of lambdas, and like with discard, or you can now use the underscore in any amount of the lambda parameters to say that we are not going to use it, it's just discards. So also, if you miss the attributes for local functions, I need to say sorry, the language does not have it. And 4 years ago I created a ticket to the compiler of the exception getting but for some reason the team decided it will be easier to just fully remove it. And 4 years ago the compiler supported the attributes for local functions. I did not expect this to be handled in this way, and now they're coming back. And we now can explain to the compiler in the local functions contract that it will be able to use it only if it's, for example, for null checks. So, like in cancellation token attributes, you can use it, or for local functions. We also have a number of features that will be not for everyone. I mentioned that in C#9 we have a lot of features, despite it being for a year. So top-level statements and covariance of the return values. So if you started to learn programming from C#, you probably found yourself in a situation where you open your code and there's something you cannot understand. So like class public static void, you ask the teacher what it means, and he says just magic words that are needed for the compiler to like your code, and we will probably explain. So for many people it's not pleasant. So the compiler team says that you can now skip the main method. So now you see the C#. The goal will be to just use the write line. You will need to use the console, of course. So I don't write main methods 10 times a day, and I will not be using this too often. And also, what is needs to be said here. So the executable code needs to be before I announce the first type. So the motivation is quite understandable. You don't like the classes 1,000 lines in the middle of your running code. And also you can change the runtime. You have default interface in C#9, and covariance of the return values will be present in C#9. I will use the same idea with a person student from the beginning of my presentation, and I will have two classes of apartments in a dorm, but as the dorm is in some way an apartment, I need to use the same values that the base class, and if I know that I work with a dormitory, I will still have to use the cast. It's not super convenient, so and it doesn't guarantee me from the fact that after 5 years someone will get this code and use it somewhere else, and it will just give me an invalid custom exception. And the compiler knows that the collection of students is collection of persons, so the method that returns the students can be returning the persons, and you can use that knowledge to change the return type method to something else. So in the apartment, I just have people, persons, and in the dorm, it will only be students, so no one can change this. And we can also mention some performance things. You most probably will not need to use those features, but you might need to know about them in case you need to optimize your code. So we have module initializers, micro-optimizations for memory clearing and garbage collecting. And .NET also supports the module initializations, and it has always supported it. If you wrote some C# code and didn't know about it, actually don't be surprised. They were never supported. You couldn't write it. It's a constructor that is run when your module is uploaded, before any code inside the module. So you could get it only with the bytecodes manipulations like monosecil, but now they will be supported from the box and out of the box. And imagine I have some static variable with some default value. To put that default value, this initializer needs to be run and run only once. So the runtime will just take the lock so that I can talk to my class. This is not what we expect when we just wrote one field and initialized it. So it can be critical. And now I can put this into the moment when it's loaded into memory. And I can use this module initializer, and I would need to announce module initializer in each and every case. And the compiler will just get one method that it will run in some sequence. We can also save some time on cleaning the memory for local variables. The compiler guarantees us that we will not be addressing any non-initialized memory. So if I announce some variable, then I will not be able to implement the method unless I put the value there. But if I look at the code generated for this, I will find the init line that instructs the compiler that before entering this method, it needs to nullify the memory. Why do I need to make it if I am going to put something new there? Some people even found a bug in the compiler saying that you can use stack lock and the compiler will not be updating memory. If you use it, it's been fixed, so refuse from that practice and just say skip locals in it. And by doing that, we can ask the compiler not to create, and of course it will only work for the structures without the locals in it. So it's a garbage collected language, so it will not be able to see it without direct explicit notion. We also have integer types in PTR and uint PTR were not convenient. You could not add, you could not sum it with some number. You had to do the casts and hope that the compiler will optimize this all. And the loss of performance was so huge that those native integer types were just emulated. And int and unit. The code will look like you use normal int. You can use the switches, but after the compilation, it's a pointer magic, and the attributes that it needs to be understood in that way. And the last thing, function pointers. In the bytecode, we had two instructions that you could not use directly in C#. LDFT to take the function pointer and put it on the stack, and call I, so just to take the function from stack. And now I can use it. I can announce the increment method and put the function pointer there, and use the delegate and the parameters, and just use it as a normal delegate. And to interop with some native code, this is very useful. You can say that this is an integer pointer, and you can also use it to say that it can be used to make the difference with unmanaged. I can also say that I would like to call it through a stack or through a register with a pointer. And if you monitor the news closely, that you probably heard that we planned the new parameter checking syntaxes, null parameter checking syntaxes. It's moved to C#10, and there's a feature, the source generators, new programming technology by Microsoft. If you are interested, then just come tomorrow to a presentation about C# source generators. Write code that writes code. That will be it, really. That's all from my side, and if you have any questions, I will be happy to answer them. Thank you, Andrey. I think we are super ready for C#9 now, and I also highlighted the features I will be using in my projects, and our viewers see now the number on their screen, and they can call it and ask Andrey directly. And I will ask a question that I had in our chat. It was a question from Ivan Migalov, and he asks about record structures. Will we have record structures? I think yes, because originally the compiler team considered record class and record construct. They refused from it, I don't know why, but now they plan to support record structures in C#10. I think it will be, it is really needed, and the compiler team usually works on those features. Well, cool. Let's wait for the next C#. And if someone finds interesting bug, yeah, then the features may maybe no, I'll find. There's a C#9 syntaxes. Do you think it will be supported in our old versions of runtime frameworks? Not everyone is moving to the latest framework versions. Well, the language syntaxes is processed by the compiler, so you can use it with .NET Framework, definitely. And we only support interfaces that are available in .NET Core, and with the return values covariance, it will be available probably only in .NET 5.